Today I'm at Cole Diagnostics. This is Dr. Ryan Cole's laboratory. Of course, we've had him on speaking as a pathologist on many of the issues around the COVID vaccine. I want to see it with my own eyes, and Dr. Ryan Cole is going to give me that opportunity. So let's go in and see what this lab's all about. Right, Dr. Ryan Cole, brother. Good to see you, man.
Great to have you in Idaho, my friend.
Oh, it's good to be here.
Welcome to Cole Diagnostics. Welcome to the lab. Let's do a quick tour and do some science.
All right, sounds good. See what you got going on.
All righty. So this is where the magic begins. This is where all the specimens roll in. Blood, microbiology, molecular biology, biopsies, you name it, we do it. Early on in COVID, the hospitals were lagging and struggling. As you remember, the big labs early on is where everything was going, but it was taking too long. So
Right.
we started early and tried to ramp up for helping the community. This is kind of the sports car of amplifiers
Okay.
in terms of being able to take a lot of patients and throughput continuously as well. Over here is kind of the heart of the lab. Here on the Architect, we do all the different chemistries and thyroid panels and you name it. That machine pretty much is the workhorse. On this side, we do the tissue processing, and here at the microtome and this water bath, they cut the slides into thin 4/1000ths of an inch sections, and that's what comes to my desk each day is the biopsy slides.
You are a pathologist for decades now. How many years?
26 years.
Have you seen anything that resembles these types of clots before?
No.
Never.
From around the country, from coroners and embalmers, I have received some samples and specimens from, unfortunately, the patients that have not made it.
Okay.
Now, me personally, I've done about 550 autopsies. And when you do an autopsy, yeah, the blood congeals, but it tends to be red and jelly-like and soft, almost like Jell-O. But these have been coming out of individuals' bodies at the time of embalming, blocking, large stretches of vessels in the arm or the leg or in the lungs. Or I have some coming from a surgeon in another state who has been removing these huge rubbery carotid plaques. And so the normal composition of a clot should be fibrin, platelets, some trapped white blood cells and whatnot. These are firm and rubbery. Patients do form deep vein clots, but the consistency of those clots is different than this. They're not white like this. They're not firm and rubbery. They're not, if we pull these out and put gloves on and squish them, they bounce back.
And obviously coroners do this all the time.
They do, and that's...
They're sending this out because something's bothering them.
Something's
right?
bothering them. So this is what I would normally see at autopsy. Some red cells, some trapped white blood cells within the middle. That's a normal post-mortem clot there. A little bit of kind of that magenta in the background, that would be fibrin strands. But what you don't see is just thick casts of all fibrin. It should be mixed elements. See kind of that greenish bluish glow. So that's true beta-pleated amyloid. So that's a special type of a protein congealing. But if I go and I look at the clots themselves, haven't had that same glow to them. And I've looked at about 20 of them with this Congo red stain. My next step is spike protein stains on all of these to see is there spike protein deposited in those protein sheets. But like this entire, this is one of those spaghetti strands, and it's just one long line of protein just congealed together. That was one giant clot that came out of a vaccinated woman, and it came out in the shape of the inside of the uterus. And I've talked to OBs left and right that are seeing this. The sad thing is, it just takes that much of a blockage in a medium-sized vessel to now you can't get red blood cells past that, you can't get oxygen past that. You get a heart attack, you get a stroke, you infarct your lung, you infarct another organ. You can't perfuse around this.
Is that that thick? Is it that
That's
wide?
That's wide, yeah. This type of clot, it's different in consistency, color, size. It's just a completely different consistency. And have I seen clots 500,000 patients later? You bet I've seen clots.
Yeah.
Clots like this now. And talking to other colleagues, other pathologists, hey, have you seen these? No. Coroners? No. This isn't normal, folks. There's nothing normal about this.
In some ways, it's nothing short of a horror movie, but to get to the bottom of how this story is being written, what's really going on here, it's my honor and pleasure to be joined by Dr. Ryan Cole.
Dell, good to see you.
I just want to thank you. We have worked hard to get you here for this. You are a very busy man. I mean, not only do you do this incredible work you're doing, you are flying all over the world trying to spread the truth, you know, as I am. We are trying to wake up every single soul on this planet that we can. We're in a crisis.
We are.
It seems. And you were at the event. Let's just for a moment reflect on that event.
That event was phenomenal. And I talked to a lot of people around the world, and they congratulated Senator Johnson for his seeking of truth and allowing, you know, all doctors agree when you censor the ones who don't. So to have those who are such brilliant minds and scientists together in one room, it was such an honor, and it was such a feeling of, this is truth coming forward in a way it should. And this is the dialogue all of society should have been able to have all along. Yeah. It was an amazing experience. Yeah.
We're here. We spent, you know, some time in your laboratory. Let's sort of begin with these clots. And I'm going to be clear right now. I think we get sometimes there's sensationalization around these conversations, and we are in a sensational time. If we looked at all the things we just talked about, you know, in our sort of hot headlines section. But I don't want to be sensational about this. I really want to get down to what we can and cannot prove, what is and isn't. And it's what we said yesterday, actually, behind the scenes when I was sitting with all of the doctors and scientists that were going to speak. I said we're all at different levels of what's going on here. What this event needs to be is simply what we can prove. I don't want to hear that we believe it's a bioweapon or that we believe that people are being killed on purpose or any of that. That's speculation. Doesn't matter how much it looks like it adds up. This is science. This is science right now. And though behind closed doors we can have theories and discuss them, when it comes to going to the public should only be really aware of what the scientists can prove. And that's what we're focused on right now.
Right, and in science, what we know is the tip of the iceberg. Even what we're discovering now, it's still the tip.
Right.
And there's so much more to learn.
Right.
And it's that willingness to look for it, but it's also the ability and or the permission to do so. Now, good science, usually all the great discoveries are accidental, but when you suppress the ability of scientists to look, you'll never find.
Right. And to put out information. And what's really, I think, damaging right now, the scientific method is gone up in flames. But even these papers where we're seeing retractions all the time, that just, it goes against what science is supposed to be. If people have issues with something printed, those papers used to have that argument. If you have something against this paper, please state it, write it out. And then someone else would weigh in. And this is how science, and in the end, sometimes it's like, you know what, you were wrong. And it would sit there standing the test of time saying, yeah, I was wrong, and I got to look like an idiot for the rest of my career, because that doesn't get taken down. Enough scientists beat on my hypothesis or my discovery that it didn't hold up. This idea that before it even gets to the debate is being taken down.
Right.
Is really, really, it's the end of science if we continue to allow this to happen.
And you bring up a great point, because real science should always involve humility and the willingness to say it's not about my ego, it's about an issue, and we're trying to get to the best scientific truth we can with the methods we have now. And obviously science advances, but it is super frustrating to have very good science in the literature being pulled for no good reason.
So let's get into these blood clots for a moment, and it's these post-mortem blood clots, and we've seen these around, if people have been, watching, it's sort of all over the internet. But someone said to me yesterday, that was at the panel, I won't say who, but they said a relative passed away, and the coroner or somebody said to them, well, I know they weren't vaccinated. And how did you know that? Like, because they were easy to embalm, they didn't have any blocked arteries. Now, That's a pretty outrageous statement. I'm not going to put that on the embalmers, people that you're working with. But what is happening, and the reason these clots have come to attention, is it's these embalmers that are trying to just fill the blood vessels with all the fluid to embalm, and is not going through, right? It's getting
Correct.
blocked and stuck, and like, what's in there? And they're pulling these things out of veins and arteries all over their body. Is that essentially what's going on?
Correct. And what's interesting, you'll hear coroners say, well, we're not seeing this. Well, when we do an autopsy, the coroner, the pathologist, we're usually doing, a brain exam, a chest cavity exam, but they don't usually do the periphery. So they're not generally, dissecting out those veins and arteries that the embalmers use.
Okay.
So why aren't they seeing a percent? Well, we are seeing them under the microscope. They're just not maybe seeing the giant ones that the embalmers are. And it is unusual. And when did it begin to happen? Well, after the rollout of an experimental injection. And you can tell, at autopsy, we do see clots, but they're post-mortem clots, and they're jelly-like. They're not firm like these ones, and we'll kind of go into.
Let's get into the slides. You have a bunch of slides to take us through. So first, I think we start with this idea of spike protein in the cells, right?
And to be honest, I mean, at the beginning of the day, COVID was clotting disease.
Okay.
COVID itself, the spike protein from COVID, caused clotting.
Right.
But that spike protein, this injection we used, that gene sequence makes your body make that spike protein. Well, we know from countless studies we'll get to that the spike protein is excellent at inducing an unusual pathway of clotting. So we'll kind of get to this
So to be clear, the virus itself can clot, but as you said yesterday, and many sort of backed up, they brag that the body's creating more spike protein through injection
for a
than it is
long
through
period
a viral
of
load,
time.
for a long period of time. And there's also been a manipulation of this spike protein. We've gotten to some of that science here, but to make it last longer than it would naturally on its own.
Correct.
And now we don't know how long it lasts, biopersistence and all of these things came up in
those
the
very
discussion
concerning things. Yeah, how long does it last, and what is the persistence of a sequence in your body making a toxic protein going to do over time? Right. So I guess we'll dive into the pictures and show some of those.
Take me through this.
Okie dokie. So this is, the vaccine, little lipid nanoparticle, has a gene sequence, goes into your cell expresses protein, and then your body makes an antibody to that cell. And then in the laboratory, now a cell that may have that spike protein in it or on its surface will make a little tag antibody that will bind to it, and then we make it glow with different chromogens. And so here,
so you get kind of a dye that when it sees spike protein, it lights up.
It binds and then it lights up. Exactly.
Okay,
so that's how we can tell it's there.
Okay.
Present or not present. We can do this with thousands of different proteins in the human body.
Okay, great.
Okay, so here we go. You were told this is an overlay of a needle going into a muscle, and you see that little circle is a venule. And you're told the needle goes in your arm, the shot stays in your arm, good to go, right?
Right.
However, there's tears in all these little microvessels. And we know good technique wasn't used, aspiration of the plunger wasn't done. So now this lipid nanoparticle doesn't just go where it's injected, it goes into a pressurized blood system. And here's deltoid muscle, there's that dye, you see all those dots.
We're looking at the brown spots?
The brown spots,
the brown is what the spike protein
those are all
is.
our muscle cells with spike protein in it. That's what, that should be there if their technology is doing what they said it was going to do.
Great,
However,
that's where you want it, in your deltoid.
Right, okay. However, we'll go forward here. Well, here's periappendicitis, inflammation of the appendix. Let's look at the next slide. See all those little brown dots? I'll be darned. That's spike protein in the appendix. Well, how did that get there?
Right.
Well, because that lipid goes everywhere, and then that S1 fragment of the spike and the spike itself can circulate for a long time.
So let's hit this really quick. Let's pull out from this slide just to get this clear. You have this sort of lipid nanoparticle that was really designed, and you said this, and just to be clear, it was designed to cross the blood-brain barrier so they could deliver chemotherapy to people that had brain cancers. So this product was made to get outside of the system it's injected to and get to the hardest place to get
to the hardest places.
The brain that's usually protected from outside elements. And so when they wrapped this spike protein or this, this mRNA technology in this lipid nanoparticle and told you it's going to stay in the arm, that defies all reason, because the product itself was made to do exactly the opposite of that, which is not stay in the arm, to get everywhere throughout your body, including your brain.
We have 20 years of papers in the literature looking at this delivery device. They knew what it was going to do and where it could go.
Wow, okay. All right, let's get back to the slides.
All right. So here, another patient, spike protein in the bronchioles. So this is, again, just over and over I'm going to show you.
Yeah.
Spike protein, dots, spike protein, again, bronchioles. This is a foreign body reaction to some of the inflammation and the cholesterol that breaks off walls. We'll skip to the next one.
Okay.
Skip that one, please. Skip that one. Okay, this is the brain.
Okay.
And that is, all that blue dot is basically the brain being gobbled up to mush. That's inflammation just destroying the tissues of the brain.
So everywhere there's those little dark dots.
That's an
you don't want that
inflammatory
there.
cell. That's a white blood cell reacting to something. Well, what's it reacting to?
Okay.
Let's jump forward. That's what it's reacting to. That is spike protein deposited in the tissues of the brain. Does spike protein belong
So this,
in the
I'm
brain?
assuming if we're looking at this is a person that has not survived. Is it a brain
Yes,
tissue?
these are sadly, and this is honoring the dead and letting them speak from the experience they had, and they're speaking from the other side, saying to us, do the science and honor what we went through.
Right.
I mean, and this is really honoring others. There's a blood vessel in all those brown dots. That's the blood vessels inside the brain, but you can see the brown dots outside the blood vessel.
Yeah.
And again, like you mentioned, blood-brain barrier, sacred in the human body. And these are going across that barrier, and some of those lipid nanoparticles are going into the supportive cells, the oligodendrocytes, replicating in your own cells, inducing other inflammatory cells to come in. Who's heard of brain fog after an injection, or even after COVID? That spike protein will induce all that inflammation, and now those neural pathways aren't firing at their normal rates.
Right.
So that spike protein goes everywhere. That lipid nanoparticle goes everywhere, and then it induces so much inflammation in the body to the degree that it can cause these sudden deaths. And I know we'll get into the clots in a
Let's
second
get
here
the clots.
too. Yeah.
Let's do it. Let's keep it rolling.
Keep it rolling here. Let's see, what do we have next? Okay, this is the lining of a blood vessel.
Okay.
And that whole rim of brown is all spike protein. So if nothing else, it causes inflammation of the blood vessels, potentially throughout the entire body. Now, once you have that inflammation on the lining of the vessels, now it starts to trigger stickiness in cells, be it your platelets, your red cells, your white cells. Next one, please. Same, next. This is in the lungs. And see those big tubes, those long snaky things, those are the clots that we're talking about. And all that brown dot within that, that brown dotting is spike protein in the middle of these clots. Now these are medium-sized vessels in the lungs, but you have a clot in your leg that gets thrown up to your lungs, and now it fragments and plugs your lungs vessels. Now you can't breathe.
Wow.
So that's spike protein. There's a close-up showing that brown dotting within that clotting material. And again, that spike protein will induce this. And we'll go on to the next one, just slide after slide after slide, you can see what this is doing.
Yeah.
Okay.
And then, so now let's get into the clot, the actual clots themselves. Or was that, did we just see them? I forget, is there more? I think we cut some
We
clots.
cut some out. The clots, we have some, overall gross picture. That was all microscopy under the microscope, but I think we do have some of the big, there we go. So this is a patient, she's still alive.
Okay.
And this is interesting. A colleague in Germany sent me this. And she got 3 shots and would get pain in her fingers and toes. It's called Raynaud's phenomenon, whenever the temp would drop below 72 Fahrenheit. And they drew her blood, and setting it on the desk, fibrils started forming. And they spun it down, and then this big glob formed. And so this was analyzed, and it's unusual proteins. And this is what the spike protein is doing. It's inducing clotting pathways that can bypass normal ones. Here you see on the left, this is also taken from a living patient, thankfully. So when the critique comes that says, well, these are post-mortem clots and it's only happening after death. No, this is happening in living patients.
Well, I'm thinking, I think about this, and again, it's anecdotal, I don't even know, but like Al Roker, we're seeing these news headlines of people going in having clots taken out all over their body. I'm not saying he got the vaccine, I don't know, but under the current climate, it makes you ask this question as we're looking, is this just being caught ahead of time versus it hasn't killed someone yet? Hopefully they're able to stop it, but there's a lot of stories like that. What is this clot made of? I mean, so it's fibrin. I mean, you said usually there's more blood involved, but it's white like this.
Right.
They're pulling it out of veins. It's the exact same shape as the vein, as though I took caulk and filled a vein. It's filling it in and then just stays in that
right,
shape.
and that's what they look like. And so here you see some of these thick elastic clots, and they do have normal blood elements. And what's unusual is this one on the right, because that's from an artery. That is a long artery clot. Not a vein clot, an artery clot. So they will have red blood cells and white blood cells and fibrin trapped in them. But additionally, there's this proteinaceous material and some sugars too. And there's some studies that suggest the higher your blood sugar, the worse you do. It makes your blood stickier. Our blood cells have glycoproteins on them. So your blood group, O, A, B, whatever it is, it's a different sugar on the surface of your cells. And so because of different blood types, and your blood sugar chronically over time, you may have a higher propensity to form some of these clots. But it's this protein material, it's this thick, really dense folded protein that's hard to break down. Now you can break down a normal clot. There's anti-clotting medicines that have been used for many years and new ones that have come out. And there's some supplements that work as well for breaking down clots. But this type of material, it's an amyloid-like material. And Dr. Pretorius out of South Africa, and I've communicated with her a couple of times, and she's fantastic. And she's done a lot of the really forward-thinking, focused on just this area. And she's proven the makeup of these. And she's found these in post-COVID patients, post-long-haul patients, post-vaccine patients. And she's characterized it in the medical literature very well. And we're continuing to study the mechanisms as to why. And she has these great little microtube studies where she watches them form. And you can take platelets out. Here's one of Dr. Pretorius's paper.
Okay.
You can, and so, the platelets are the microscopic band-aids in your bloodstream, and they'll form these little patches so you don't leak your blood out. And so she took these studies and took platelets out and put that spike protein in, and the proteins still glom together, even in the absence of platelets.
So we would assume the platelets are what are binding. She removed platelets from the blood, still put the spike in there, and found that it's able to build proteins. Well, is it almost like upon itself, or what is it?
It's like, an erector set or Legos, and you just keep sticking one to the next, to the next, to the next. But it's a pretty strong protein bond, and it's just tough to break these apart. And so the body's normal mechanisms for breaking things apart doesn't appear to be able to do this. And we've known this for a long time in medicine. Amyloid is a very concerning condition in medicine, and there's other medical conditions that can cause amyloid deposition. Different tumors and lesions will cause certain abnormal proteins to build up. There's specific ones that will cause an amyloid-like protein to form, but this is rare, it's not common. And so these clots, and to see them at this rate, especially after a certain program rolled out with an experimental gene and a lipid nanoparticle, et cetera, all of a sudden we're seeing something we haven't seen before. That's scientifically very concerning and should be looked into even more. Like I said, we know the tip of the iceberg. We're still working on more mechanisms and understanding more of the makeup of these things.
Are you under any impression, because I know you're in the middle of this, that the FDA, the CDC, the NIH, clearly this is a problem being seen around the world. Independent scientists around the world are looking into it. Are our regulatory agencies that have sort of supported this vaccine, are we aware of any studies going on right now looking at this really alarming problem?
Crickets. Where's the funding? As many billions as we have spent to different companies and agencies to advertise, get a shot, those same billions should be going into the research.
Yeah.
And you're right, I've been overseas quite a few times this year, talked to colleagues, they're seeing it, morticians overseas, they're seeing it. So it's not just here and just a couple of labs, and a lot of morticians have been seeing it, but they want their job, and so they're staying quiet, but they're sharing material and information.